In this video, I'm going to look at the collinear and midpoint formula. So whenever we talk about points of which are collinear, we mean that they lie on the same line. So, like if you wanted to visualize that, then, we could think of it like this, that we have, points P and maybe R and then Q. And basically what we know is that, the distance from P to R would be right here, and then we have the distance from R to Q would be right there. But in any case, we would know that basically, if in fact they are on the same line, then that means that this should be the distance from P to Q. So in this case, note that we have a set of points right here, right? We have that we have P, which is 1, 2. We have well, let's say R, right? Because we're using R. We have 2, 3, and then we have Q is 3, 4. Now, notice that if we find the distance for each of these respectively, then the distance from, let's say, like P to R, that's going to be equal to the square root of 3 minus 2, which in this case is 1, plus 2 minus 1, which in this case is also 1. What does that give you? It gives you the square root of 2. But then if we find the distance from R to Q, well, the distance from R to Q is basically going to be 4 minus 3, which is 1. So that's going to be also 1 squared, plus 3 minus 2, which that's also 1 squared, of which that gives you root 2 actually, right? Now, if we go ahead and we find the distance from P to Q, then basically we're doing the exact same thing, aren't we? We're just finding that the square root is going to be 4 minus 2, which in this case is 2 squared, plus 3 minus 1, which in this case is 2 squared, which is the square root of 8. Now, basically, if points are collinear, we have to have essentially that let's select a different color, maybe here. We have to have that the distance basically from P to the PR, plus the distance from R to Q actually, right? The distance and then P to Q. We have to have that this must be satisfied, right? Okay, well, what happens is that with this particular example, using these points along here, it should actually work out in either case. Why? Because they do lie on the same line accordingly, right? But let's see. We have root 2 plus root 2 equals to root 8. Now with the calculator, we can actually verify this most definitely, but let's check this out. This is going to be 2 root 2, but notice this. What is root 8? Root 8 is actually going to be 4 times 2, which the square root of 4 is going to be 2 root 2, and what do you know? They are equal. What this means is that the points P, Q, and R, they are P, Q, and R, in fact, are what is called collinear in either case. Now, you can actually try a similar example, like if I had I had the 3 points, like let's say like we have that A of -5, 7, and then maybe we have another point, call it B, -4, 5, and then maybe we had another point, maybe call it C, and that's going to be 1, -5. you can check to see whether in fact these 3 points are in fact collinear. How are you going to do that? You're going to have to find the distance from A to B, plus the distance from B to C, and this must equal to the distance from A to C. Now, it actually doesn't matter the order of which that I label these points actually, but just as long as there's consistency. And just so that, we can find the answers in either case. Now, if you do go ahead and do this problem, you actually should find that A, B, and C are in fact collinear. So yeah, it'll be collinear. Now, one thing though that I will mention about collinear is that essentially you have that, if they in fact do lie on the same line, then that means that, visually you have something like this, like where you have a set of 3 points lying along the same line. So what that means is that basically if you have something like this that are collinear, basically A, B, and C do not form a right triangle. Similarly, if you have a set of 2 points in the x and y plane, of which that they're joined, actually not 2 points but 3 points, so like if you have something like this, then that means that essentially that, for these points, like if this was A, B, and C, this means that these 3 points do not form, they're not collinear, but they are forming a right triangle, and vice versa. You have that, A, B, and C, if they lie on the same line, they're collinear, they cannot form a right triangle. Interestingly enough, the difference of being collinear and being a right triangle is the following. If I square this, and I square this, this would give me a right triangle. But, in this case, we're just looking at collinear. Now, if you just rewind and you just look at that formula again, then in that case, you'll actually know, how do you verify that something is a right triangle? Well, Pythagorean theorem, right? So what we'll look at next, though, is, okay, well, this idea of, having points that lie along the same line, this gives us this idea of what is called the midpoint. Now, in either case, we could probably look for the midpoint, for example. How? Well, let's say that we just considered like x1, and then we had x2, and then we had that this is going to be our midpoint. We'll call it M. Well, M is basically in the middle of x1 and x2, right? So in any case, what we do have is that their distances respectively should be the same, right? Because then in that case, like if this was equal to A, then I know that this has to be the same, A also. So how would I figure that out, for example? Well, in any case, I would know that, we could come up with a formula, really. We could come up with a formula, and we can say, okay, well, in any case, we have that the distance of x1 minus m, if I take the absolute value, that should be equivalent to the distance from x2 minus m, right? And basically these are equal if and only if that well, what you would have to do probably is to figure out a formula for this one, because we know that, yeah, that their distances, they have to be the same essentially. So rather than having to solve an equation like this, because yeah, you would have to go through the process of finding that, well, let's see, yeah, you'd have to find the process of where you have x1 minus this, and then this is equal to negative x2, and then that's going to be minus that part. But, rather than doing this, it's actually a lot easier to just say, okay, well, what we can do instead is just say that, well, because I know that this is exactly the middle of the points x1 and x2, then in that case, it's kind of like an average, actually, because in any case, m would have to be the average of the two, where you have x1 plus x2 divided by 2, and then that gives us the midpoint, actually. So, we actually just get a formula in that sense. And and actually, if you want to go back and you want to solve using the formula, actually, I should have wrote it a little bit differently, to be honest. I think it's actually where you say that x2 minus the midpoint is equivalent to, in this case, it would have to be probably the midpoint. Yeah, because if you're going in the direction, that's going to be minus x1. So yeah, there's our actual proof, in a sense, that we can solve for the midpoint using this method too, because we know that they're equidistant, right? Okay, so similarly, this tells me that if I have points x1, x2, well, let's do it like this, not x2, but y1, and then I had q is going to be x2, y2, then in any case, the midpoint similarly is given by the average of the 2 points, x1 and x2. Let's write this a little bit better. And that's divided by 2, and that's comma x1 plus x2. Actually, it's not x's, right? Sorry. So it's going to be y1 plus y2, all divided by 2. And then in any case, this is our formula, right? So we have our nice formula for the midpoint, and, it's not really anything too special because, yeah, it's really just the average of the two in either case. Now, interestingly enough, if you have that you're looking at a midpoint, then technically they are collinear. So that's what I was kind of like saying, is that, when we think of a collinear, essentially you have that the midpoint demonstrates that exactly. Now, in any case, like if I wanted to, let's say for example, look at finding the midpoint of a particular set of 3 points, then in any case, we could probably look at, for example, like if we have the following 2 points, let's say that we have P of -5, comma -3, and we have that Q is 9, 3. Then in this case, the midpoint is equivalent to the average of 9 minus 5 divided by 2, comma, well, -3 plus 3 divided by 2. And then basically this gives us the following. It gives us that the midpoint is equivalent to 4 divided by 2, so that's 2. And then -3 plus 3 is 0 divided by 2 is 0. So this gives us the midpoint, essentially. So we found our midpoint in actuality through here. Now, one way of which that you could probably work this out, for example, is say, for example, that we had that one of the points was already given, okay? So suppose that one of the points is given, and that's 0, 12. But then let's say that the midpoint was given also. And if we say that the midpoint is, let's say, like 4, negative 4, then that tells us then what is the endpoint that we can call x, y. So this is actually a very nice question, because essentially it just has that we just need to use the formula, right? So setting this up, how would you do this? You would have to set it up as, well, basically we know that 0 plus x divided by 2, comma, 12 plus y divided by 2. And what do we know? This is equal to 4, negative 4. So what this does is it gives you the equation x over 2 equals to 4, and it gives you 12 plus y divided by 2 equals to negative 4. I'll leave it to you to solve this because, this is just a linear equation, right? You can solve for x and y respectively, and it's going to tell you that the midpoint, or not the midpoint, but the other point, q, of x, y, that's basically going to be the solution is that you find x. So what is x? X is going to be 8. What is y? Well, y is going to be basically negative 20. So in that case, we know that q is going to be 8, negative 20. I know that I said that you should try it, but in either case, at least you have the solution, right? That you can have that is the midpoint, not midpoint, I'm sorry that I keep saying midpoint, but yeah, that's the endpoint in either case. And I wrote it purposely like this so that, I have it lined up essentially. But it might be in the wrong order, right? Because, actually, maybe not. Yeah, 8 minus 20, if you were to graph that in the x and y plane, yeah, you would have that this would be exactly the proper order. You have the p, then you have the midpoint, then you have the other endpoint in actuality. Now, in the next few videos, we're going to look more at some graphs, and they will require knowing the distance formula and possibly the midpoint formula, respectively.